everyone, and welcome to AP Stats. I first wanted to introduce myself, even though you can't see me. My name is Mrs. Burke. I am happy and excited for you to take AP Stats, and I look forward to you joining my class in September. Thank you for tuning in to the AP Stats Summer Assignment. We are going to be taking notes in the notes portion of the assignment. So before you do anything, make sure you have your yellow packet handy because I'm going to be directing you to what pages everything is on. And I'm going to tell you here and there to stop the video so that you can do the problems. We're going to do all the notes together and the lesson together for chapter 1, and then you're going to do some practice problems here and there as I go. All right, you should be looking at the packet at page 3, and on the top of page 3 we have this information. So let's find it. And it says blank is the science of collecting, analyzing, drawing conclusions. That's statistics. I'll just write stats for short. And the thing that is going to be described that we care about is called an individual. So someone who we're interested in knowing something about, it could be a person, it could be an animal, it could be a plot of land. It's an individual. And we're going to look at something that is about that individual. That thing that we're interested in measuring, that attribute that we're measuring is called a variable. And we're going to be talking about all different types of variables this year. The two types of variables that we're going to talk about are categorical variables and quantitative variables. The categorical variable is another name for it is a qualitative variable. And another thing to say is it is not numeric. So it's something that it doesn't make sense for you to take the average of. Can't take the average of this. Basically, we're just placing people into categories based on something they have in common. So, what are some examples of this? Are you a righty or a lefty? What grade are you in? What's your favorite color? What is your favorite local pizzeria, etc. Okay. That's going to come up a little bit this year, categorical variables, but mostly we're going to be focusing on quantitative. So quantitative variables, you see the word quantity in here. These are numeric variables, numeric quantities, and these it does make sense to find the average of. Does make sense to put it on a number line, on an x-axis, and also to find the average of these things. So any kind of numeric quantity. Examples of this include your height, your grade in math last year, the number of hours of sleep you got last night, whatever, you get the idea. And all those things, we can add them up and find the average of them, right? So we're mostly in chapter 1 going to be focusing on quantitative variables because those are a little more important and more prevalent, but we will see categorical variables a little bit. So what are we going to do this year? The first thing we need to know is we always want to talk about the population. We're interested in the population, which is a larger group of people or things, right? So maybe I'm interested in all the fish in the ocean, but that's a really big group, and it doesn't make sense for me to actually get all the fish in the ocean and measure their length. That would be like totally unreasonable and time consuming and crazy and just not doable. So what we're going to do is take a small sample from the population, and that is a smaller group. And we take that sample directly from the population of interest. And then we hope that that group will represent the population well. So we're going to talk this year about how we're going to be designing a sample and what makes a good sample and what makes a bad sample. So we take our sample excuse me, we collect data from it, we plot it, we analyze it, and we make an inference from the sample about the population in hopes of generalizing about the population of interest. That's basically the whole year. So guess what? You're done. You can leave. Check out. All right, so we're going to start with categorical data. This is going to be very short and to the point. Categorical variables are less prominent, as I said. So we're going to turn to the top of page 4 of our notes packet. What is categorical data? We said it before. Places people or things or individuals into categories. And again, we said it's not numeric. How can we address or analyze categorical data? All right, so the charts that you might see are a bar graph. In the news, these happen a lot. A pie chart. And also we can use a two-way table, which is something that if you took Algebra 2 and Trig last year, you should have seen the two-way table in the probability and statistics unit. So let's see down below an example. So here we have a table and we have a whole bunch of information about people in a sample. We asked them what province are they from in Canada. So provinces in Canada are like states in the United States. So that is categorical. We asked them what was their gender, and that is also categorical. Then we asked them how many languages do they speak. So as soon as you see something numeric, that is quantitative. So I'm going to put Q for quantitative. Then we have the handedness. Are they a righty or a lefty? That's categorical. Their height, numeric. So that's quantitative. Their wrist circumference, also numeric. So that's quantitative. Their preferred method of communication. So do they want to speak in person, on the cell phone, text message? So that is categorical. It's listed here, but I'll just write it again. And it looks like they're interested in this bar graph over here and analyzing this column. So we're going to look at a categorical variable, preferred communication style. So if you look over on the right, you see a bar graph. This is a bar graph. And one thing to know about a bar graph is the bars don't touch. Okay, if they did touch, that would not be a bar graph. That would be called a histogram. So as you can see on the x-axis, which is this axis here, you have the categorical variable that we're interested in, which is their preferred communication method. And you see there are 4 categories within: the cell phone, Facebook, in-person, and text messaging. And it looks like what they did was they found out how many total were in the sample, and they found the percent breakdown of each group. So they did the percent of people who like to use the cell phone, and in fact, they found that was 20%. And then Facebook, 10%, etc. So if I had to describe this bar graph, I would just say with one quick glance, it looks like the majority, actually it's not the majority because majority would be more than 50%, but I would just say the greatest proportion or percent of people prefer texting as their method of communication. So if somebody asked me to analyze this graph and write a sentence or two about it, I would say the greatest proportion or percent of people prefer text messaging, which is true these days, right? I'd say. Followed secondly by in-person communication, and then by cell phone, and then the last one was Facebook. A lot of you don't use Facebook anymore, but you probably use something else. Now if you look on the bottom of the page, you see that they took this information and they organized it into a frequency table, a relative frequency table, and a pie chart. So the frequency is basically the count of how many people fall into each group. So the total amount is 10 in the sample, and that is the total sample size. And then it looks like they have the breakdown of 2, 1, 3, and 4. And then they took those numbers, 2 out of 10, 1 out of 10, 3 out of 10, and 4 out of 10, and they got the percents over here. And another name for percent is relative frequency. You're going to see these words interchangeably this year. Relative frequency, percent, proportion, probability, they all mean the same thing. So now we have a pie chart over here, and this pie chart also displays categorical data. And notice that it's the same data from above in the bar graph that we just saw in the form of the pie chart. So you have the greatest percent of people are text messaging, and then followed second by in person, then cell phone, and the smallest percent is Facebook. All right, so there you go. There you have your categorical data in the form of your bar graph and your pie chart. So now I want you to turn to page 5. And on the top of page 5, there is an example. And the example says, Mr. Starnes is thinking about buying a new car. He has narrowed down his choices down to 10 vehicles. Here is the information. So we have information in this chart just like we did on the last example. Part A, identify who are the individuals. So write down who are we measuring about. And then for part B, list all the variables. So I want you to list every variable and then classify each one as categorical or quantitative. You could just write a C or a Q. All right, so take a minute, stop the video here, and do this example. Now we are done with that example. We're going to be in the middle of page 5. And we're going to look at this piece here, analyzing data of 2 categorical variables. So what if we want to put 2 variables together? Well, what we can do is we can create a two-way table. So a two-way table displays 2 categorical variables for a single group of individuals or a sample. Okay. You have seen this if you took Algebra 2 and Trig. So it looks like we have information about, are you a member of the environmental club? Yes or no. And that's categorical because we're just asking them a question, yes or no. It's not numeric. And then also, do you own a snowmobile? Do you own it? Do you rent it or never, etc.? So in this case, we are creating a two-way table. As you can see down below, we have a row variable and a column variable. And I'm specifically going to look here on this one in the bottom left corner here, okay? So think about the Excel spreadsheet, okay? You know in Excel there are rows and there are columns. The rows go across, so picture in an auditorium, rows go across, right? And columns go up and down. So picture like the White House has columns, right? Or the Parthenon or any kind of important building. So rows go across and columns go up and down. So in this case, the rows we have without totals are 3. We have 3 rows. And the rows are never used a snowmobile, rented a snowmobile, owned a snowmobile. And then the columns that go up and down, there are 2 columns, yes and no. Okay, so if we were to describe this this two-way table, this would be called a 3x2 matrix because there are 3 rows and there are 2 columns. No totals involved there. Now, if you look on the bottom right, I'm going to highlight it in yellow, you see 1526. That is the total in the sample. And I'm going to say it all the time, that's the total. So you're going to have row totals, you're going to have column totals, and then you're going to have total. So whenever I say total, I mean that number on the bottom right. So it looks like that means that there were a total of 1526 in the sample. And the letter I'm going to use this year to determine sample size is the letter N for nectarine. So if you see N, that means sample size. All right. So hopefully this should look familiar to you because you've seen it in Algebra 2, if you took Algebra 2. All right, now we're going to turn to page 6. Top of page 6. When working with a two-way table, we can either go down the margins in the rows or the columns, or we could do something a little different. So if you ever see the word marginal relative frequency, you only are caring about one variable of the two. So you're either doing the row total divided by the total to get the percent, or you're doing the column total divided by the total. Okay, so it depends on what you're interested in. If you look here on the right, it looks like they have never, rent, and own. So never, rent, and own are the rows. So it looks like they're doing the never total divided by the total to get 43%. The renter total, 574, divided by the total to get 38%. And then the own total, 295, divided by the total to get 19.3%. So basically, as you can see, these are the rows totals divided by the totals. And that is going to give you the breakdown of just who owns, rents, and never used a snowmobile. If you had done it the other way, down the columns, which is what this other piece says here, we could have done based on if they were a member of the environmental club, yes or no. So I could just have looked at the no and the yes out of the total. So 1221 no, right here, out of the total, and 305 yes, out of the total. Okay, so that breakdown of just the column variable is 80 to 20. 80% are not a member of the environmental club and 20% are. However, often we're not going to look at one or the other, we're going to look at both. So as soon as you see both variables at the same time, you're going to be doing a joint relative frequency. So both is actually going to be the intersection of the two variables. And if you took Algebra 2, you learned that the symbol for intersection is this symbol. It's the and. Okay, so that is just a little side note. You're going to see that this year in the probability unit. So basically, you are concerned in this case with where they meet, where the two variables meet each other. And you want these people to be members of both groups. So that's what this says on the right. A joint relative frequency helps us answer questions involving both of the variables at the same time. All right. So let's look at a follow-up question. Number 1. Example, what percent of people in the sample are in the environmental club and own snowmobiles? So they said yes, they're in the environmental, and they own snowmobiles. So the notation you're going to see this year is going to be the word yes, and you could either write the word and, or you could put a little intersection symbol, own snowmobiles. And then I'm going to put a big P on the outside, and that means probability. So we're going to look for where the yeses meet the own. So I'm going to go to the top here. I'm going to go back to my two-way table. I'm going to get rid of some of my markings here. And I'm going to look at where the yes and the owns meet. So yes is here. These people are in the environmental club. Own a snowmobile is here. Okay, so where they meet each other, or where they overlap, is the joint frequency. So I'm going to circle that in red here, and that's going to be 16 people are members of both groups. These people own snowmobiles, and they're also members of the environmental club. So to get the probability or the proportion, we're going to do 16 out of the total of 1526. So then that's what you see down below. 16 is where they meet. That's the intersection out of 1526. Intersection out of total. Okay. And notice that's only 1%. So only 1% of the sample are actually part of the environmental club and own snowmobiles. That kind of makes sense. It's kind of rare because why would you care about the environment and own a snowmobile, right? All right, so now you try number 2. What proportion of people in the sample are not environmental club members and never use snowmobiles? So we want to say not and never. So this is going to be not and never. All right, so look that up, stop the video and do that, and then we'll move on. Now on the top of page 7. The other thing that we can do when we're doing a two-way table is to put a condition on something. So you saw this if you took Algebra 2 trig. If we want to put a condition on something, we're actually going to be restricting the denominator of our fraction. I'm going to write denominator, denom for short, to only the row total or the column total, depending on what pool of people we are looking at. So take a minute to write that down and then I'll explain. Restricting the denominator of our fraction. So before we did it out of the total, so we did it out of this number on the right, 1526. But this time we're not going to do it out of the total. They're going to put some kind of restriction on it. So they might see a keyword. They might say a keyword like of the snowmobile owners, what's the probability they said yes? They might say the word among. Among the people who said yes, what's the probability that they're a snowmobile owner? They might say the word if. If they are a snowmobile owner, what's the probability they said no? And then the last one, the most important one, is they might say given that. Given that they said no, what's the probability that they're a snowmobile owner? So if you see any of these key words, I wrote words, but whatever, let me rewrite this. If you see any of these key words, those are going to signify that you're going to go, instead of out of the total, you're going to go out of the row total or the column total, not the total, okay? So here is an example. What percent of environmental club members in the sample are snowmobile owners? So I don't know if you realize it, but there's the word of here. So that, whatever comes after that buzzword of, is actually going to go in the denominator of the fraction. So out of the environmental club members, how many of them are snowmobile owners? So basically you're going to restrict your denominator to only those who are members of the environmental club. Out of the environmental club members, the people who said yes, they're in the environmental club, how many of those are snowmobile owners? So out of the environmental club members, 305 of them, how many of them are snowmobile owners? 16 out of 305. Snowmobile owners. 16 of them out of 305. All right, that's it. So then you would just convert it to a percent and you would be done. So the main thing is just knowing that you're not going out of the total, you're going in that case out of the column total, and you're only restricting your pool of people to these people. And you then out of those people, these people out of there are who you're dividing. So now I want you to try on the bottom of page 7 these questions. So these questions now are going to take you through basically all the skills that I just went over on pages like 1 through 7. So answer A through E. Stop the video now and answer A through E.